my name is Yolanda Tanner, and I oversee the STEM program at the Naval Information Warfare Center Pacific. Today we are here in lovely San Diego at the historic and monumental Transdeck facility. And we are so excited to have you with us here today. Today we will be talking about underwater remote operated vehicles. And with me today I have Rachel, who is an electrical engineer at the Warfare Center. Say hello, Rachel.
Hello.
So as we go along, we want to thank all the students and parents and families for joining us today as we go through this underwater ROV lesson that we're going to go through today. And first we're going to start with some questions, and we're going to find out a little bit more about Rachel and her journey into STEM. So Rachel, first of all, what sparked your interest in STEM?
So I kind of got started in STEM back in elementary school. My grandparents were taking me around during summer vacation to visit all the different national parks. And at the national parks, I was part of the Junior Ranger program, and I learned all about different Native American culture and geology and lots of biology, and that's kind of what got me started.
So as you begin to explore these things when you were young, and with the parks and with the hands-on, how did that transition into electrical engineering as a student in college?
Well, that's actually kind of a long path. When I was a kid, I actually didn't want to be an electrical engineer. I really wanted to be a paleontologist. But as I got into high school, I kind of transitioned more into biology, actually. So that's still in like the STEM umbrella. And my biology teacher had me apply for the BWISE program, which stands for Better Education for Women in Science and Engineering. And I was able to get into this program, and they hosted several events within like the STEM umbrella. And they hosted a few different boot camps and a few lessons. I remember went to some supercomputer facility at UCSD, and it was really cool, and all the science that they were showing us was just really fun to learn about, and that's really what got me jump started into like the STEM in general. What got me on the track for electrical engineering was an internship that I actually had here at, back then it was called NAVWAR, now we call it NAVWAR. And it was a 3-month internship, which was paid, so as a high school student, I was like, yeah! And it was down at the Robotics Center, which overlooks Point Loma into the water. It was a beautiful environment. And I was assigned to create a little component for the PackBot robot. The PackBot is about this big. It looks like a mini tank almost, and you can put different arms on it. But I was assigned to put a little extension piece on it, and you would put a proximity sensor, and when you're driving the robot, you could see if it was about to drop off of a cliff or like a steep hill, and then it would stop and do its thing. But what was so cool is, I was able to like pick up the software and design this little part, and I had the resources to print the part there on base and get it on the robot within this period of time. And I remember one day we just spent the entire time driving around the robot trying to like trip the sensor, and it was just so much fun. And I was like, this is my job, I'm driving around a robot. And I was looking around at my coworkers too, and everyone was like super chill. They were like really motivated to help you if you had any questions. And so there was definitely like that work-life balance going on as well. My mentor actually wasn't there for my last day because he was surfing in Mexico. Mm-hmm. But yeah, everyone was super friendly, relaxed, and the projects we're working on were very interesting. Mm-hmm. So that's kind of what got me onto engineering in general.
Awesome. So as you talked about your earlier days with your family and exploration, and then talked about that collegiate part of your journey into electrical engineering, can you talk to some of the students, whether they're in elementary school, middle school, or high school, and give them some tips on how to move forward with their interest in STEM or learning about STEM?
Yeah. I would say get involved in any way you can. You know, there's lots of programs out there that organizations have that can help you get involved in STEM in your area. I know one really good one is the first robotics competition. I actually mentored a high school team, and it was really cool. We put together this robot that had the competition's so in depth. There's all sorts of different things that the robot has to do in the competition, and it's a really good program to get into. But for like middle school students, there's the first robotics league too, where you get together with like maybe 5 people and put together a little robot that solves a puzzle. So there's lots of avenues out there to get involved, but you really want to get involved when you're in like high school and even middle school, and see like where your passions are, so that when you're ready to apply for college, you know kind of where you want to go. And then also you don't want to go and get your 4-year degree and then realize that you actually don't like doing this. Mm-hmm. So it's definitely get out there, get involved, find an internship, even do a hobby electronics if you're into electronics. I know there's more than that in STEM, but yeah.
Right. So you're saying that there's this connection that students can be involved in things. They can want to be a scientist in technology, engineering, math, and it doesn't have to just be a vision. It can be an action. Mm-hmm. While you're in school, while you're out of school, as you're going through those years before college. And sounds like you're saying, just get involved, just do it.
Yeah.
Just do it. Okay. Now, my next question is, I understand, and when I first saw you, when I first saw Rachel, it was 2015 here at this Transdeck. This Transdeck is a competition site every summer for over 20 years. Every year I walk this site. It's usually the last week in July, and I talk to every team. So in 2015, I went to the SDSU table, and Rachel was there as one of the team members. So Rachel, tell us about how you got involved with the SDSU Megatronics RoboSub team while you were in college.
Yeah. So in college, I remember I was sitting in one of my classes, and I overheard some students talking about a new club that was trying to compete into the RoboSub competition. And I had actually visited RoboSub back in 2009 with the BWise boot camp, and it was such an interesting event. I was like, oh, when I get in college, I really want to work on this. But SDSU at the time didn't have a team. So when I heard them, I was like, oh, how do I apply? How do I get involved? And so I was actually part of the inaugural year of the Mechatronics RoboSub team. And it was a really fun adventure. It was only about seven of us at the time putting together our robot. And, being an inaugural team, you don't have a lot of resources to you. So we had to put together this little demo robot so we could show it to sponsors so we could get funding, which was really great for me personally because it kind of got me out of my introvert shell. I was a pretty big introvert in high school and through a big part of college, but as I was kind of forced to talk in front of these sponsors, it kind of helped me see oh, talking in front of people isn't so bad, I can do this. And it also helped having such a great team there supporting me as well.
Right, and you talked about this was SDSU's first go-around in the RoboSub competition. You talked about, sometimes, funding isn't there for the biggest grandiose thing. So what are some of the elements, what are some of the elements that you think that were crucial because your team won that year?
We won the following year.
You won the following year. So the first year you competed, and the second year you guys won the competition. Again, I have walked this competition for probably over a decade, and many teams compete, few place. So to say that a team in its second year of inception into the competition is a phenomenal accomplishment. So what are some of the things you feel that made the team really embrace the challenge? And was it more about winning, or was it more about what you learned along the way?
Oh, it was definitely more about winning. We were an underdog both years. And we just had a really good team that just had a lot of determination. That's what a lot of this is for, is like, it's your heart has to be in it, and you have to love what you're doing and be really motivated to just complete the task. Like, not even winning, just like knowing that I made that and it did something that is phenomenal. So I think that's really what like drove us, is just like our own desire to like make something awesome. Like, it wasn't really just about the winning.
Right, right. And in that, I hear you talk about the drive, being driven towards something. And I think that's something that we should all do in whatever career or path we take in life, is the drive to do it. And something else I want to pull out of that team environment, can you tell us a little bit about how the team members are constructed? Is everybody an engineer? Is everybody a computer scientist? What are some of the other disciplines that really have to come together for a team to be successful, whether it's RoboSub or whether it's First Lego or any other competition, team competition?
Team structure is critical to a successful team. Our team was amazing because we had like a sponsor team that dealt with all like the boring paperwork, and then we had the engineering team, and we had, well, the engineering team was broken up between the electrical, the mechanical, and then the computer software. So a big part of RoboSub is the visual processing. It's completely autonomous when it's in the competition. So you really have to have a really good visual processing system, which is one of the reasons why we had like a team dedicated to that. But you don't want someone working on all those things, because they'll just be a jack of all trade, master of none type person. And you really need someone to be a natural, a master at each one of those.
Right. And that competition also pulls in marketing, correct? A technical presentation. So I think one of the students that I have met at these competitions, they have students from the business department, they have students from the marketing department, and I think it kind of breaks down the misnomer that when you're in STEM, you're only doing STEM. No, you're surrounded by people from all disciplines and all walks of life in order to really be successful on whatever that project is. Correct?
I mean, building one of these ROVs is just like a mini company. And in a company, you need multiple different departments, and that's kind of how you should structure your team.
Awesome. So, so as we go into our next portion of this about the underwater ROV, we found out that in the San Diego Unified School District, there are hundreds of students who are currently working on an underwater remote operated vehicle project. However, due to COVID and the pandemic, they have not had the opportunity to have a lot of hands-on on the school side or within the pool. So right now, we're helping those students to kind of bridge that gap between questions that they might have about their project. So first of all, I want to thank all the students and all the faculty members, parents who are doing their best at home to make sure our next generation is educated, and you're doing an awesome job. Before we go into the questions, Rachel, I want you to take us through some of these things that are on the table. I am not an electrical engineer. I have viewed the RoboSub competition. I have viewed underwater ROVs. It does not make me an expert. So if you can take us through some of these fundamental things that students use during a basic ROV project, we'd really appreciate it.
Yeah, sure. So these are the components that are in your basic pufferfish kit, and that's what the students here will be putting together. Some of the key things to look at are the control system, which is essentially just a couple of dip switches that will connect the battery to the thrusters here. And it'll basically just turn them all the way on or all the way off in the forward or reverse direction.
So in this project, could I call that the brain?
Yes.
Okay.
Yes.
Okay.
Yes. So yeah, here's the brain, and then I guess these would be the feet or the legs.
Okay.
But these are our thrusters. I know propeller design is another key aspect of the project. These would probably be all right for you guys. You might want to get one that's a little bit bigger. Having a propeller that's almost the size of the thruster is probably a little preferable. But since we're going full on or full off, these guys would probably do the trick for you, especially because you might almost get too much power as you're trying to delicately do a task to accomplish your mission.
Okay, so I got a brain.
And
then I got some thrusters to give me some momentum under the water. Okay. All right. What else we got here?
so you also need a frame to put your thrusters on. And so we have some examples of the PVC pipe that you'll get a few of the PVC pipe joints in your kit, but you'll have to purchase your own PVC pipe, the bigger struts here. Yeah.
So when I get some PVC pipe, I pick this up from the local hardware store. Does it have to be special? Does it have to be fancy? Does it have to be expensive? Or just PVC pipe? I think this is a 1/2 inch. This is 1/2 inch PVC.
Yeah, so I mean, if you're going to be using the joints that came with your kit, you'll want the 1/2 inch. Doesn't have to be anything special or expensive. There are fun colored PVC pipes, so you might want to do that to give your butt a little flair. But
All right.
I don't see anything wrong with painting this PVC pipe either.
Awesome. Awesome. All right. Let's keep going.
One of the other key things are the control line here, which you'll be connecting between your thrusters on your housing to your brain controller through this piece here. I know there's a lot of questions about soldering things underwater, and for this, it's probably best to look up a YouTube video, which we can link to you guys.
Awesome. All right. So I got a brain over there. I got the thrusters, going to give me some momentum. I got my PVC pipe from my local hardware store. And then the wire. Tell me a little bit more. Now, is that why I'm using PVC with a hole through it instead of a dowel that's solid core?
Yeah, so you can put the cord, probably this cord here, from your thrusters that you have attached to it. You'll drill a little hole and stick your wires through it.
Got it. Okay.
If you don't want to use a drill, you can just go ahead and use your fancy duct tape.
Awesome.
And wrap that around your PVC pipe as well.
Okay. Alrighty. And then the last thing we have here is the local generic pool noodle. So what would I need a pool noodle for? Now, I know I could use a pool noodle to noodle in the pool, right? But what am I going to use this for in relation to this project if I'm not using it like a headrest while I'm in the swimming pool?
All right. So your ROV might be kind of heavy when you put everything together, and so it will sink and won't have enough buoyancy to rise up. And depending on your mission, again, a lot of these design aspects are dependent on your mission, but you might want it to float up in the water, or you might want it to be neutral in the water. And so you can play games by attaching a pool noodle to one of your PVC pipes and add some buoyancy to it.
Awesome. And this is kind of like trial and error to see how much you want it to go down or how much you want it to rise to the surface.
Yes.
Right.
There is a chance that a lot of air will get caught in your PVC pipes themselves. And so it could potentially just be buoyant on its own.
Right.
So you might want to attach some type of weight on it. I was just brainstorming on the way here today, and I was like, maybe get like a bottle filled with sand that you could like tape on, and then you could take sand out if you needed. But those are just some random ideas.
Oh, or what if I just had a little net and had some washers and stuff?
Yeah.
Okay, something that had some density to it, but I can remove it or put it back on to see where I want to sink or where I want to float. Awesome, awesome. All right. So thank you for taking me over that. Oh, I'm sorry, with the red and black.
Yes, so this is a fuse that is very critical. It needs to be installed between the battery and your brain electronics, because if water does get into your system, this fuse will blow, and then you will not get electrocuted yourself. It'll keep you nice and safe.
Awesome. Kind of just like at our houses.
Yes.
We have our house, we have an electrical box, we might have a fan, we might have an air conditioner. Oh, we probably have a computer or a laptop, and we want some type of protector there in case there's some sporadic voltage so it doesn't harm our brain, our computer, our stove, or whatever, correct?
Yes.
Awesome. All right, are you ready for some questions?
Yes.
All right, so the students from Kearney High School have formulated some questions that they want to ask you. So let's get to the questions. These are in no particular order. So Miguel Guerrero asks, he wants to know, how far can you communicate with your robot underwater?
Right. So it kind of depends on what form factor you're dealing with. So for your robot, it will be only as long as your cable is. A lot of the robots that you can buy out there actually communicate via a cable similar to this, which is actually called an umbilical.
Okay.
But there are some type of ROVs that can communicate over the satellite. If you look up wave gliders, actually, they're completely controlled over the satellite, so they have infinite range. So it all kind of depends on just what your mission again is and how your robot's set up.
All right, and fill us in on this thing. So there's the tethered or umbilical cord. You talked about a satellite. What's the difference, or is there a difference between those two and autonomous underwater? Or like when you did the RoboSub competition, because, correct me if I'm wrong, once the robot is in the water, there's no umbilical cord and there's no data signal. So would that be considered autonomous or no? I don't know.
So I believe it said to communicate with your robot.
Right.
So
right.
if you're communicating with it, you're connected. You can't
Got
communicate
it.
with an autonomous vehicle.
Okay, awesome. Okay, because so if you want to communicate with it, your best thing to have is an umbilical cord or a tether when you're
You want to
communicating.
get instant feedback from it.
Awesome. All right, Miguel also wants to know, how do you seal it off so that water doesn't get into it?
Right. So that's going to be the electrical joint that you're going to have to make here. There's an example of it here, which we had initially connected to the motor, but we took it off for this demonstration. But basically what you'll do is you'll strip two ends of the wire, and just for purposes, I'm going to attach these guys. You put them together like this, and you apply some solder. And then you'll put hot glue over that joint, and then you'll also have a piece of heat shrink. You'll pull that over the joint as well. And then you'll apply your heat gun, and it'll remelt the glue a little bit and shrink the solder over it, or shrink the heat shrink over it and keep it nice and safe.
Okay,
So that's how generally these type of robots have
awesome.
those joints.
Now, on the same note of wiring, Jaden Chavez wants to know, where should you put all the important wires? And I will say there's probably a million ways to do things. So, so in your opinion, where should you put all the important wires? Should it be alongside the PVC? Have you ever run it inside the PVC?
So it's safest to put it inside the PVC.
Okay.
But I would say when you're first designing the robot, you should have it duct taped on the backside until you know where you want to put your thrusters.
Oh.
Because when you first are putting together your housing, you might want to move your thrusters different directions a
Got
little
it,
bit.
got
And
it.
if you've drilled your hole, then it could be difficult
Ooh.
to move it. So that's just an idea.
So we can just use like some duct tape. So it's like measure twice, drill a hole once.
Yes.
Okay. And then after we test it and say, yep, that's where I want it, then drill the hole.
That's
Because
what I would recommend.
otherwise you're going to be patching holes or buying new PVC.
Yes.
Okay, awesome. All right. And Owen Arnold wants to know about design structure. I'll worry about that later. He wants to know about design structure. And we just have, the straight PVC. And what are some things that students might want to consider when they're designing their frame for their ROV?
So it definitely depends on what your mission is, because you need to know like what different types of components you need attached to the robot in order to complete your mission. So like you could make it as small as possible, but then if you decide you needed to add a scooper, you wouldn't have anywhere to put it.
Okay.
So for like a beginner project like this, I'd probably stick with just like the standard frame that if you, again, Google some of like the other puffer fishes, which just looks kind of like a cube, and you can attach different things to it. And then that's like your first demo butt, and then as you know what you want and you're more advanced in your skills, you can maybe shrink it down to the specific frame that you need.
Got it. So part of it sounds like you're saying what you're trying to accomplish or your mission or your objective should drive your design.
Yes.
Just like a lot of other things in life, whether it's a phone, whether it's a computer, whether I'm hiking, whether I'm biking, whether I'm taking a road trip, I have to decide what do I need for what I'm going to do when I get there or along the way. So that's awesome. All right. So Ethan Wong wants to know, what do you do, or what type of things do you do as an electrical engineer?
Yeah. So I'm really lucky here at NAVWAR because I get to do everything on the bot from schematic to test. So I'll go on the computer and I'll design the circuits and I'll lay out the boards and I'll get the boards and I'll test them, and then I'll put them in the ROV and then I'll go test them out at sea, which is pretty fun.
So when you talk about a board, is that a PCB?
Yes.
Which stands for?
Printed circuit board.
Is there one in there?
There is.
Awesome.
If you can see it on the screen maybe, there's a little green board in here, and that is a printed circuit board.
Okay. Now, as an electrical engineer, like this one with this kit, it came like that. So do you sometimes find that based on your mission or your objective that you have to design a special printer circuit board?
Yes, yes.
Oh.
For ROVs, we definitely have custom printed circuit boards to integrate with our different sensors or different types of motors in order to get our mission accomplished.
Okay. And Bridget Morales wants to know how many of these ROV projects, now you have to go back, you got to go way, way back, have you participated in, whether it was high school, whether it was elementary school, whether it was college. So what started, you talked about first robotics. So what kind of started, and you talked about biology, so I see that love of water and things that we've talked about, but what started that transition into the physical, I'm putting my robot underwater?
Yeah. Well, that kind of goes back to why I became an electrical engineer. I wanted to work on interesting projects. And part of that, I worked so hard in college, I was like, I'm not just going to make like little tiny chips to go into something. I want to make something cool. And so that's what put me on the path of to ROVs. And that's kind of how I found myself here.
Awesome. All right. And I'm going to go to Edgar Macias. Edgar Macias wants to know, what was your biggest challenge in becoming an electrical engineer?
Well, electrical engineering in general is one of the hardest majors. So definitely probably the classes themselves. They were very difficult, but I believe, you know, if you're determined, you can do anything you put your mind to. And I think I am a case for that because it was a struggle and I had to study a lot, but I'm here.
Awesome. And how about we're going to go to Paul Acuna. And I think this is very common question in the STEM realm. And sometimes students are told, hey, the money is good. So, but I want you to tell us about, is it only the money part or is it interesting for you?
Yeah. Well, it's definitely interesting. I mean, as I said before, I work on really interesting projects, and most forms of engineering will pay fairly well. You know, I live a good life. But yeah, it's definitely fun. That's why I'm here at NAVWAR, is because I get to work on really fun projects.
Awesome. And then we have a question from, give me a minute here. I want to make sure I get the student's name right. It's Stephanie Ventura. She wants to know, how are we supposed to work together when we can't be here in person? But I want you to kind of frame that in terms of when you were with your team in college, you guys weren't always in the same room. So how do you keep a project moving with more than one person, just like we do it here at the center, when everyone is not in the same room? What are some tips?
Well, as we kind of went over before, like, you really got to structure your team and figure out who's doing what. And you guys probably should have like a kickoff meeting with your team and decide on like who's interested in doing what and assign tasks and whatnot. There's actually a lot of online resources to help you collaborate. In mechatronics, we actually heavily use Slack, which is kind of like a direct message type of application, and you can even talk in different like group chats as well and upload files. It was really useful for us. So organization and using your online tools, like I know a lot of you have already used Google Docs to collaborate on documents as well.
Awesome. So it sounds like you're saying having that team come together as a team, whether in person or at a distance, is crucial in this project or any other project. Awesome. All right, we have a couple of more questions, and this is Isaac Avia. He wants to know, what is the longest project, time-wise, that you've ever worked on?
I've been with my team since I started here 5 years ago, so I guess 5 years technically. But yeah.
So project what? Oh, so you're saying that you've been on one project for 5 years? Awesome, awesome, awesome. All right, and we're gonna do our last question from Marco Ramirez. What are your strengths and weaknesses?
Oh, wow, now I really feel like I'm in an interview. I would say my weakness is probably stretching myself a little too thin. I'm very busy at work. I have a problem saying no to new projects. Like I said, I really like working on a bunch of different things and learning about different projects we have here at NAVWAR. But sometimes I take on too much work. But on the flip side, one of my strengths is that I'm very determined. That's how I got through college with these difficult classes, and I can like put the pedal to the metal and get the job done as well.
Now, what would you say about work? A big phrase for the last 9 months has been work-life balance. So what are some tips would you give about work-life balance in relation to project, deadlines, managing family, friends, and in this environment?
Yeah, so again, back to the online resources, like, you know, video chatting with friends is awesome to stay connected. I think that's really important right now, as people just aren't socializing as much. They've also been great for our team working together. It's actually made us use Teams chat a lot more, which I think has been very beneficial because we don't have to run over to someone's office and ask them a question and then run back, or, you know, I hate talking on the phone. I'd rather just type something up real quick and send it to them and get a one-word answer.
All right.
You know, so that has been helpful for us. Yeah, but definitely it has been a little difficult to like separate work and home balance, because my dining room table is, you know, it has my TV set up as an extended monitor for my computer. So we've been like eating in the dining room, and then like I'll work a little bit later because I'm just like coding down there, and then I'm like, oh, it's 6 o'clock. I worked over too long. So
Right. Yeah.
it's definitely making those separations and how to manage your time and yeah.
Absolutely. Okay, so as we wrap up, I thank you so much for being here. I really appreciate it. And again, I remember seeing you in 2015. I'm like, oh yes, she came to our organization, and she's a great, great electrical engineer, because it's so great to see students who are in elementary school, middle school, high school, and college who are tinkering with stuff, who are doing things and experimenting, and it's just awesome. But we're going to test my knowledge now on what things that you've said, so as we wrap up here. So for basic ROVs, I'm going to have a brain with a printed circuit board. And then in addition to that, I'm going to have something that gives me some momentum, which is my thrusters, right?
Yes.
So I'm going to have the yellow something has a propeller on it to give me some momentum. And then I'm going to use some PVCs, just standard, nothing special, to make some type of frame. And you said usually the fundamental starting frame is some type of like cube.
Yes.
So I could say, hey, I'm going to make my frame to be like this long and this wide and make it three-dimensional. All right. And then I am going to, I'm not going to run my wires through the frame first. I'm going to kind of mount it on the outside to see where I want it, and then decide where I'm going to put the holes to run the wiring.
Yes.
Then let's say I'm ready to go ahead and put that thing in the water. I got it waterproofed, it's sealed, all my soldering is done. And then I put it in the water and it stays on top of the water. It doesn't sink, it's just floating. So you're saying I might have a lot of air in here. So to compensate for that air, I might want to get something that gives me some density and weight that I can put onto my frame so it can sink a little bit. But then if it sinks too much, I can either take some of that out of the bag, or I can start experimenting with something like pool noodles for some buoyancy.
Some combination.
Okay,
The
or a
weight
combination
with
of
density
both.
and the pool noodles.
Absolutely. And then I also have to look at, you know, if I got all that together and I think I want to, now I know I have a specific mission, then I might want to look at my frame design and things that I might want to improve.
Yes.
Was I a good
Say
student?
that's good. A+.
All right. So I want to say thank you. We want to say thanks to all of you for joining us for this segment today on underwater ROVs. And we hope that this is the first of many engagements that we will have with you through the internet, and whether it's face-to-face or contactless, whether it's COVID or not, this is something we really want to continue. So thanks for letting us into your homes today.
Thank you.